Okay, I hope you enjoyed that animated video by Khan Academy explaining average and instantaneous velocity. So average velocity is the velocity of an object over an extended period of time. And instantaneous velocity is the velocity of an object at one moment in time. And as they explained on the video, instantaneous velocity is just when we get to a very small amount of time. And he was explaining in the video how you calculate these average and instantaneous velocities. So how can we use a graph like this to calculate an instantaneous velocity? Well, we know that the velocity is the change in x divided by the change in t. The change in position divided by the change in time. Now, you guys have been dealing with graphs for a long time. And if you remember the equation for a slope, it's the rise over the run. But when we look over at our graph, we see that the rise is going to be the change in position. Our run is going to be the change in time. Again, this graph is a graph of position versus time. So since the velocity is the change in x, change in position, divided by the change in time, the velocity is actually the slope. It's the change in position over the change in time, the rise over the run. So the slope of a position versus time curve is the velocity. This is important. The slope of a position versus time curve is the velocity. And you can learn a lot, or you can tell a lot about an object by looking at its position versus time curve. Like, for example, first question says, during what interval is the object's speed the greatest? Well, if velocity is the change in x over change in time, the rise over the run, where would the object's speed be the greatest? The speed would be the greatest where the slope is the greatest. Where on our graph is the slope the greatest? I believe that the slope is greatest down this portion of the curve right here. So I would say during this interval from point D to point F, this would be the area where the object's speed is the greatest. The next part of the question says, what is the instantaneous velocity at 4.5 seconds? Again, we can find that instantaneous velocity as the slope at 4.5 seconds. So let's see, 4.5 seconds is going to be here at point D. What's our slope at point D? D is actually the vertex of going up and back down. So what is the slope at point D? That slope would be 0. So the instantaneous velocity at point D is actually going to be 0. Guys, point D kind of corresponds to, like, if we think of our ball rolling towards the wall, point D would be the wall. At this point, the velocity actually equals 0. The slope of this curve at that point is 0. And the last question says, what is the instantaneous velocity at 6 seconds? Well, we come over here to 6, we see that that's point E. So we're trying to find out the instantaneous velocity at 6 seconds. So we figure out what the slope is of the line passing through point E. And we can say that the velocity equals the change in x divided by the change in time. So looking at our change in x, let's see, 2 would be our final and 9 would be our initial. Or 7, we can go with 7. Divided by 9, we're at 9 seconds, final, minus our initial time, where E is at 6. So 2 minus 7, we get a negative 5 divided by 3. Plug in our calculators, we're going to get a negative 1.7 meters per second as that slope. Note it's negative 1.7 meters. It's a negative velocity. It's going down. It's actually decelerating. So it hits the wall and it's decelerating until it stops.